Yep. Okay. So today the mini course is an introduction to Space Index as an evidence-based design tool. And we will go through processing QGIS and having a look at the Space Index toolkit. The structure of today, which is starts, let's say, roughly 10 to 1. In the first part, which I will present, we will talk about the theoretical underpinnings of Space Index, and we will go through some Space Index terms. Then Mariam will go through an introduction to the Space Index toolkit and what it measures. And then we have Frixos and Walid, who will go through spatial analysis using the toolkit, types of analysis, and then ways of interpreting the results. And we will do this in different parts. The first part is mostly presentations, and then the second part will focus on actual exercises to understand a bit, simple exercises to understand how we actually perform spatial analysis and how we interpret the results. So in the first part, we will look at the theoretical framework based on two very well-known books of Space Index, and we will look at theories underpinning Space Index, such as natural movement, movement economy, and so on, which I will go through in the first part of the presentation. Space Index was developed around the 70s. It was developed by Bill Hillier and Julian Hanson and other colleagues at University College in London. At the beginning, it was a way to understand how modernist council estates, why modernist council estates failed. But more generally, it focuses on understanding and simulating the social effects of design. Hence the title of the first book of Space Index, which is called The Social Logic of Space. It's the key publication and the key text about the theory and the tools of Space Index. And this was published in 1984. Following this, there was a second publication in 1996 by Bill Hillier, which is titled Space is the Machine. And following that, the Space Index Symposia started. They are biannual, they take place every 2 years, and they started in 1997. Also, a bit later on, in 2010, we have the publication of the Journal of Space Index. This approach is now used by hundreds of universities, practices, and so on worldwide, and there's a variety of research applications, some examples of which we will see today. So let's have a look at some basics of Space Index. I think the most important thing is to talk about what it is. It's both a theory, but it's also a method. It includes a number of tools for describing the patterns of spatial layout in a quantitative way and relating the results and these patterns to social practices, such as movement, behavior, and so on. In this approach, movement is considered as a linear process during which visual information changes from point to point. That is, in the way that we move, our visual field and visual information that we perceive changes. And interaction, social interaction and inhabitation, they require spaces where we can visually see everything. They are called convex spaces. And in these spaces, we can see all points can see all the other points. A very important term in Space Index is configuration, spatial configuration, which actually it means the relations taking into account all other relations. So it's actually a relationship among parts, for example, urban streets, all of which interdepend in an overall structure of some kinds. And this concept, the important thing about this concept is that it addresses the whole of a complex rather than its parts. There are some terms which we need to know and get familiar with. So one is what I just mentioned, spatial configuration, the relationship of one space to all other spaces in a system. Then it's graph theory, and we will see later on types of graphs. So a graph is a collection of nodes connected by edges to create these relations between them. And the spacing between the buildings in cities, or the organization of space within buildings, which is the space syntax. So in language, syntax refers to the ways in which words can be arranged to create meaning and underlying rules for the arrangement of elements. Here, in space syntax theory, the term refers to a set of underlying principles of spatial arrangement that subconsciously, as we move around cities, we experience. And these are based on the network properties of urban space. This is what spatial configuration is about. And basically, space syntax proposes two important things. The first is that space is not neutral, it's not a background to human activity, but is a part of it, is intrinsic to human activity. Second, that space is first and foremost configurational. So what happens locally in one room, in one space, is influenced by the relationship with all other spaces in which the space is connected. So it's relational. It's not, you cannot look at a space individually. You have to see it in relation to all other spaces and that this space is connected to. It's very important that space in space syntax theory is not just where actions take place. It has specific relationships to and influences those actions. So there's a reciprocal relationship. And there are relationships, key relationships between space, between urban form. Urban form relates to movement, it relates to land use distribution, it relates to economy, economic vitality and land value, to crime and safety, to sustainability in relation to low carbon emissions, sustainable modes of transport, active travel, and so on. And all these have been studied through hundreds of case studies, and we will see some examples later on. How does space influence human behavior? It influences it because people move along lines. They interact in spaces like the one we can see in the picture, in convex spaces. And as people walk, they perceive changes in visual fields through their walking as they move around through these spaces. There are three very important concepts in space syntax theory, and we will look at what each of these is. The first one is about the generic city and a dual grid. They call it a foreground and a background street network and how this relates. The second is about natural movement, and it explains how urban space shapes movement, shapes flows. And the third is about what Bill Hillier called movement economy, how land users actually exploit movement. We will go through each. So the first principle is about what is called the generic city. And we can see examples of cities. Each city has a unique spatial signature. So for example, we look at this city of London, and then we see how this was analyzed with space syntax. Mariam will go through this later on a bit more. We can see Beijing, and then we see how this is analyzed, the spatial configuration through space syntax. And then we can also see Tokyo and how this is analyzed through space syntax. The theory behind that, the theoretical preposition on what a generic city is, supports that there is a universal city with many spatial and functional invariants across cultures. So that on one way, there are similarities across all cities. So all cities are comprised of a very small number of long lines, like the ones we saw in the analysis, and a very large number of short lines. And these make up a system, a dual system, the foreground system and the background system, or the foreground network and the background network. And these have different geometries. The foreground network what Bill Hiriel called deformed will, the proposition is that it has a more or less universal form of a network, a form that you can see in all cities. It's a network of linked centers at different scales, and this has emerged to maximize movement because of the grid, and this is driven by economy, by microeconomic activity. So in other ways, there are some longer lines and straight connections in all cities, and these relate more to economy, to land uses that relate to economic activity. And then there's another network of lines which relate more to residential uses. And this is configured to structural movement in the image of a particular culture. So this background network relates more to local cultures, whereas the foreground network relates to something more global, more universal, which is economy driven. So these are two very important concepts and propositions in the generic city. The second one is about natural movement. How do we move naturally around cities? So movement, according to space syntax, it's linear. It's a linear process. You move in lines, in a linear way. As you move through space, then you see things. So as you move through space, the information visually available changes. Space syntax modeling, the tools that you will see later on, they already embed this relationship between human experience of space and the physical form. So the tools that will be described to you later on and analyze spatial relationships, they already embed the human experience through vision, the way we see things. So configuration, as determined by geometrical and topological parameters, affects our notion of distance. These factors are involved in navigation much more than metric properties. So it's not about distance, it's about how we understand distance in relation to visual information that is afforded to us by the spatial configuration. So we do try as humans to minimize distance, but we also try to straighten the lines in front of our eyes, the lines of sight. And we will see examples of that. So let's take this example. So let's say that this is blocks, the white is streets, and we need to go from A to B. How would we move from A to B? Would we choose the shortest path, which is this one? So this is the least metric distance. This is the shortest distance that we can travel. Or do we choose the simplest path, meaning that we don't change a lot of angles? We choose the path with the least angle change. It's very interesting that observation studies, many observation studies that were actually done on field in real cities, they have shown that most people prefer simple, more direct paths over complex indirect paths, even if the complex path is shorter. So the studies have shown that we choose the simpler and more direct path rather than the shortest path. And this is a very interesting example where you can see that a path was created by people by choosing actually the simplest rather than the shortest path. So more or less, we can say that consciously, we try to do both. We try to minimize distance and we try to straighten our route from A to B. How good we are at either depends on how well we know a place. We know that locals and tourists move somewhat differently in space. If you know the space, you move in a different way. So how easy it is depends on how space is designed, whether it allows to follow the most direct route or whether you have the means, let's say, to cheat through choosing another route which was not designed actually. So if we are able to do that, this is what happens when design does not match the human nature of navigating through space. So, I mean, we know that because of evidence-based design with tools that analyze that and observe that. And this is another very interesting example in Michigan, where in this university, the university didn't put in pavements when the new buildings were created, and instead they waited for students to create their own paths. So you can see that these paths were not actually designed from the beginning, but these were created by natural movement of the students. That was a really radical approach to design the configuration of their footpaths to connect their new buildings. And this was quite interesting because they let the users create their paths through everyday natural use of space. And you can see how people tend to walk and navigate through space. Let's see a video. Can you see the video? And then I will go through it. This is a very famous crossing in Tokyo, the Shibuya crossing. It's also known as the Tokyo Junction, which is a crisscross junction or a scramble crossing. They designed it in such a way so that it enables people to follow the desired line of movement across the street. So it showed that it saves pedestrians time through avoiding having to cross the road twice at the right angle, waiting for cars to go through in between. But also it eases traffic congestion through the reduced number of times that cars have to be stopped in order to let people cross. So this is an interesting example where people follow a desired line of crossing. So natural movement, what space syntax calls natural movement, is the proportion of urban pedestrian movement determined by the configuration, by spatial configuration. Now, to what extent configuration organizes movement? There have been many studies done, correlational studies, that tell us that movement flows do relate to configuration and is measured by what you will see later on, spatial accessibility. So according to many studies that took place throughout the years, 60% to 80% of movement flows relate to the structure of the network in the sense that more accessible places get more movement. An interesting question that comes out of this is that what determines the remainder, 20% to 40% of movement? It's a combination of factors that are likely to have an influence, which can include location of transport nodes, residential densities around, multiplier effect of land uses, landmarks maybe, and so on. But the important thing is that research has shown that the majority of movement flows does relate to the street network, to spatial accessibility. And an interesting study was done in Tate Gallery in London, where researchers mapped 100 people's routes within the building. And you can see the relationship between spatial organization on the left and movement on the right. And on the left, they used visual analysis, what you can see to walk through the building. The last principle that we will see is what Hillier calls the movement economy. The theory of the movement economy is that spatial organization in cities first generates the patterns of busier and quieter movement flows, and then these influence land use choices. In turn, these choices generate multiplier effects on movement with further feedback on land use choices. This theory is very important. Why? Because first of all, it tells us that commercial, in particular retail land uses, are located to take advantage of the opportunities offered by passing people, by passing trade. This is the principal factor in the distribution of land uses. So when we have these land uses, because we have more people passing through, then we have a multiplier effect on natural movement generated by the urban grid. And we have a series of spatial relations, and you will see the tools later on. First of all, the relationship between spatial elements like blocks, streets, and so on is called configuration. And these can be analyzed. They can be analyzed using many measures. I will not go in detail through them because you will see them in presentations later on, but we have measures such as integration, such as choice. These are very important measures because they relate to how we move in cities, to human movement. The first relates on the selection of destination, if we choose to go somewhere, and the second on the selection of a route, where we go through. The first measures how easy we can go somewhere, that's integration, the ease of access, and the other measures the passing flow, the choice, how we choose. So you can see, for example, this analysis. Integration in practice measures the accessibility of nodes within a spatial system. Spaces which are very deep in a system, they have lower integration values, and these are the bluish colors, while higher integration values usually correlate with high levels of movement and activity. And if we have high levels of movement and activity, we probably have higher social interaction. These are the reddish colors. So local integration has a radius of 3 steps in the system, while global integration is the integration of all nodes to all nodes in the system, to the whole city, let's say. And the last concept that I would like to talk about, and you will see later on what it means through examples, is centrality. Centrality in space syntax is a very important process. It proposes that urban centers are the outcome of a long-term historical process of the formation and location of centers. And this process entails the configuration of the street network, shaping movement flow patterns, which then have an impact on the distribution of land uses to form busy or quiet areas. And then this has an influence on land use choices and so on. What is important to note, and then you will see the examples, is that movement as well as centrality, they take place at different scales. So we have local movement, city-wide movement. We can also have regional movement, and country-wide movement. So these, in a nutshell, are the key concepts and principles of space syntax theory. And then we will move on to see how these are measured, what are the tools that we use, how do we interpret the results of the tools, and so on. So this, in a way, summarizes what we looked at as key concepts: integration and to movement, choice and through movement. And I will give the floor to Mariam, who will refer again to these terms, but focusing mostly on how and what tools we use to measure them. So I'll stop sharing. Okay, and Mariam can continue.
Good morning, everyone. Good morning, everyone. Thank you for joining today. Okay, so the next part of this presentation will focus more on the Space Syntax Toolkit and what it measures. Just to summarize what you have learned in the previous presentation by Nadia, we will be looking at a number of concepts which was introduced by Bill Hillier and his colleagues at the Bartlett at UCL, and these concepts are from the 1970s onwards, looking at the social impacts of architecture and urban design, explaining why buildings and master plan weren't working the way we expected them to. So, as we all know, people naturally pass through some spaces more than the others, and this is called the natural movement, which is about how urban space shapes natural flow. Then this leads to the movement economy, which refers to how land users exploit movement and how there are spaces that are more lively than others in the city. And this is where the concept of pervasive centrality comes, how cities can create multiple centers and overlapping neighborhoods. And finally, the dual grid, which was referred to previously as the two systems in the city, which is the foreground and the background, and how these two systems integrate together. If you would like to know more about, of course, the concepts and their use in practice, you could have a look at these books, The Sociology of Space, Space is the Machine, and some selected papers by Bill Hillier. Now, firstly, what is meant by the term space syntax? Before delving into the use of the tool, let's understand what is meant by space syntax. When we refer to space, only space, we are doing this in two main ways. First, we are interested in the public spaces, streets, squares that makes up the city, which is called the space in between the buildings or the space within the buildings. And at another scale, when we understand the word syntax in language, the word syntax refers to the limited set of ways in which words can be arranged to create meanings, underlying rules for the arrangement of elements. So, like you understand, the term space syntax here refers to the limited ways that space can be brought together to produce livable cities, livable buildings, and spaces for social interaction. Now, the Space Syntax Toolkit, as you know, the Space Syntax Toolkit is a plugin is a free plugin that you can easily install into QGIS. And in the Space Syntax Toolkit, you can find another set of tools that you can use to analyze the built environment. Today, we're not going to talk about all the tools available in the toolkit, but instead we are going to focus about the graph analysis tool, which basically performs the space syntax analysis by remotely connecting to the DepthMapX software. And we will also introduce some of the functions of the network segmenter and the catchment analyzer. So now the space syntax analysis. Okay, before using the tool, you need to understand what will we analyze. So we are analyzing the basic features of each street, length of street, number of connection to other streets. And as you previously heard, there are two main key measures. The first one is integration, also referred to as centrality of each street to all other streets in the system. It is also known as two-movement potential. And the second key measure is the choice or betweenness, which refers to the extent to which streets are likely to be used more and chosen as a route from one part of the system to the next, also known as through movement potential. The second important point you need to understand is the scale of analysis. The radius n refers to all the scales, and this helps you to understand the connectivity of a street segment to the whole or to the rest of the system, also known as citywide hierarchy. Of course, understanding the connectivity of the street to all other street segments with a given radius, you can choose that given radius according to your research question. For example, if you are studying local movement and walkability, you can choose a scale between 400 meters up to 2 kilometers. For larger city scale-wide movement, you can choose a scale up to 10 kilometers, and for region or countrywide movement, you can choose up to 100 kilometers. And of course, this differs from one city to the other. Now, one of the most important things in space syntax is also being able to look at the same place across different scales and see how important it is for movement at the different scales. For example, a street can be important for a certain type of movement in the local scale, but also in the global scale. And this happens when the reddish lines interact together. So at one scale, it can be green and then red at a much lower scale, but normally, successful centers can be read at both scales, which means that they are accessible at both scales. There are also three main properties that we explore when we look at the spatial syntax of cities. The first property you need to understand is that streets have different accessibility. Some streets are easier to get to from everywhere else, and they are better integrated. While some streets are more useful in hosting through movements, they are known as having higher choice or betweenness value. The second property you need to understand is that cities have a dual system of streets. Cities have an integrated system comprised of a foreground network, which basically refers to the main streets, and this is supported by a background network of streets, which also refers to the local streets. And the third property you need to understand is that movement happen at different scales, which overlap to produce urban vitality. So moving back to the two key measures we were speaking about, the first one is the depth or integration or two movement potential. And this basically you can use to answer research questions such as how central a street or a space is in an urban system. While the second measure is called the choice through movement potential, and this answers a different question, which is how likely a street or a space is to be moved through as people go from one point to the other within the system. Now, this is just to show you the difference between the two types of analysis. In the first picture on the left, you can see the highlighted central areas highlighting the highly integrated cores. This is the integration, while the picture on the right is for choice or centrality, highlighting the red streets, which are the routes that are most used to move through the city, often identifies high streets. So the integration is one of the key things we look at in space syntax, and it's based on the idea of spatial configuration and spatial depth. The depth of each street to all other streets in the system, not in a crow-fly distance, but rather the number of turns people would have to get from one part of the city to the other. As I mentioned before, the angle of turns. So it highlights here in the picture the principal commercial center of the city and where people move to. But we need to also understand that cities also consist of multiple smaller centers where local grids, identification, and structure highlights accessibility. This is an example of multiple centers. You can run this analysis across different scales at different radius. For example, you might want to see the total depth of every space or only within a small radius of 2 kilometers from any given point, local or global. So in this picture, you can see it picks out the local towns that are surrounded by the city areas. So you can see the multiple centers in this picture, which highlights the central area in each town or in each municipality, let's say, within a 2 kilometer scale. And this is the second accessibility measure, which is betweenness or choice. As I explained before, it highlights the routes that are most used to move through the city. It often identifies high streets. So now we can move to the second property, the dual system of streets. As we explained before, spatial networks typically combine a well-connected foreground and a less well-connected organic or natural background, and this in turn creates an integrated double-layered system in the city. The foreground network is made up of longer, more open lines and is about 3 to 7% of the total network. It creates more organic mega blocks, as can be seen in this map. The background network is made up of shorter lines and are easier to walk, and they usually finish on perpendicular angles. The background network are often more residential and with more cultural variation than the foreground network. And now finally, the third property is that movement happens at different scales. We measure movement at different radii. For example, we might go to the most accessible streets within a 400-meter radius to buy our coffee, or within a 2-kilometer radius to access our place of work. Some streets are more likely to be accessed for local trips, while other streets are more important to be used for citywide movement. But then you often get places where there is an overlap between those both local and citywide movement, and this becomes the natural centers with a high sense of place. So now we move to the next point, which is processing using Space Syntax Toolkit. And what I mean by processing is analyzing or creating spatial analysis using the Space Syntax Toolkit. Basically, what you need to perform this kind of analysis is to install the QGIS software as well as the DepthMapXNet software. And please note that this is different from the DepthMapX. And finally, the Space Syntax Toolkit, as I explained previously, it's a free plugin that you can easily install at QGIS. It is preferred to always use 2 versions of QGIS in case you occurred any kind of issues. You can always refer to the older version, and you can also refer to this link for any issues and frequently asked questions. So now we move to the toolkit. Basically, the toolkit allows you to perform a wide range of analysis, ranging from modeling to input analysis, visualization, catchment analysis, and other forms of analysis as well. Some of these, you can use it in the pre-analysis phase, such as the modeling, preparing your model, and validating your model before starting analysis. And the next steps is basically when you start to analyze your model after testing, for example, different scenarios. If you already have a model, which we have already prepared for you, that is prepared and verified, there are some steps you need to follow to analyze this model using the graph analysis tool in the Space Syntax Toolkit. So this is the first tool you can see in the Space Syntax Toolkit. And there are a number of steps you need to follow in order to perform this kind of analysis. So the first thing you do is that you click on the graph analysis tool, and then you select the model you already have. You select the segmented model for processing. You also need to tick the segment map or the road center line under the, like you can see in the screenshot on the right, under the graph analysis. And then you need to choose your radius. If you're not sure what radius you need to analyze, you can write radius n, and this will provide you with analysis for a wide range of radius. If you have a specific research question and you're only interested, for example, in local movement or global movement, you can specify your radii for urban analysis, starting from 400 meters up to 10 kilometers. Usually, the output layer by default will have the letter P at the end, which refers to processed or analyzed. And after that, you just press calculate. And please do not close the DepthMapX software while processing the model. You need to open DepthMap first, and you need to keep it running throughout the whole process. The next step, which you will be listening about more in the next part of this session, is the visualization of the results. When the model is processed and ready to visualize, you can apply a standard normalized choice style. So if you have already some styles saved, you can right-click on the processed model to access the properties. In the properties, you will find the word symbology, which refers to the style. And this is the place where you visualize the results of your analysis. If you have previously styles that you saved, you can click load style. If you don't, you can create this style for this specific kind of analysis. You will learn more about this in the next sessions. And now there is another kind of analysis that the tool allows you to perform, which is the catchment analyzer. So it's kind of a different analysis because it's more focused on the metric dimension. The metric catchment analysis This analysis uses the street network to assess which parts of the city are within a specific distance from key locations and points of interest. The points of interest can include land use, infrastructure, transport nodes, different functions such as schools, public spaces, and so on. And the metric measures we are speaking about is you have 400 meters, which refers to the 5 minutes walk. For example, how many schools can you access within 5 minutes walk? How many hospitals you can access within 10 minutes walk? So these are the different metrics you need to measure, and this is just an example of the transport attractions within a walking distance from one side. You can see the reddish lines in the center refers to the areas where you can access transport nodes within 5 minutes walking, while the bluish ones refers to further larger distance you have to walk in order to assess transport nodes. So this is another kind of analysis that is also used when you want to explain how many minutes you need to walk to assess certain attraction points in the city. Now we come to the next important point, which is to understand the outcomes. You have learned that the spatial layout have so many impacts on many different factors, from direct movement and through land use, economic vitality and land value, to also more complex outcomes such as crime and safety, carbon emissions, and even health and well-being. So at the most basic level, let's start by movement. Street systems influence pedestrian and vehicular movement. So you can see from this image how spatial accessibility shapes movement, how the accessibility of street system is identified purely as an emergent property of the street system itself, how close or deep each street is all to the others. So this has proven from a lot of studies and observations that there is a strong correlation between the spatial accessibility value of streets and between the natural or the pedestrian observed movement. So statistical effect, people still going from origins to destinations, they tend to move around street systems in a similar way. And these models have long been tested by having people counting pedestrians and vehicles on streets. So what we can learn from this kind of analysis is that this can be an opportunity for citizens and for citizen engagement in testing models for themselves and building their own evidence-based and predictive models in order to predict pedestrian movement across different projects. We also know that movement patterns also have an impact on land uses and economic activities and the potential for creating economic activity and productivity. So this explains how spatial networks shape the location of economic activities. So here in the picture on the left, the red buildings are actually retail establishments. We are used to think that normally the shops attract visitors. Shops are attractors in the system because they attract customers. However, we have come to realize that the retail location is an emergent property of street systems. And based on the street spatial accessibility value and then the multiplier effect of the shops, streets can attract their own customers. So from the image on the right, you can see the red street crossing is actually the street that have the highest accessibility value is the same street in the other picture that has the most mixed use economic commercial uses. So you can see that 80% of the shops are actually located on the 20% of the best connected streets in this part of the city. Now, I will come to this section later, but this will explain to you how we can understand some complex outcomes, some complex impacts, such as the impact on crime and safety or the impact on health and well-being. Now, this is also another use of the Space Syntax Toolkit. As we explained before, it is used to test design options. So here, for example, you have two design options, option 1 and option 2. Like you can see from the picture, the pattern of spatial accessibility created in option 2 is very strong. Take a look on the triangle in the center of the picture and how it connects, it works with the existing spatial hierarchies and is well integrated with the surrounding context, and it connects spaces with high levels of existing movement in comparison to the upper picture, which has more bluish or greener streets. Now we move to the second point. Is one of the main things that the tool helps you to understand is it helps you to understand complex outcomes. What do we mean by complex outcomes? It means that the layering spatial network with other forms of data to answer complex questions. And this is often referred to as integrated urban models. So in integrated urban models, you also integrate other variables, such as the walkability index, to answer more complex questions like where do people walk? So this could happen by combining analysis of the street networks with other local factors, such as the land use layer, the ground floor frontages, public transport. So in order to look at the different interaction between different variables in the cities, working up more sophisticated space syntax models, which takes into account other factors when looking at the walkability of the car, or for example, another aspect is the car dependency model promoted by a system. For example, the walkability index analyzes the families of land use that can be accessed within a 15-minute walk of every street. Note that the time here is not just the number of turn. It is a higher score that indicates more families of use within 15 minutes and more walkable streets. The second model is the car dependency index, which incorporates more factors, including car ownership and also accessibility to jobs with or without cars. So it can help you answer questions like, do I need a car to access job opportunities? Do I need a car to access green areas, public areas, access to public transport? Local health officials found a strong correlations between the car dependency index and adult obesity estimates. So overall, there was a strong link between socioeconomic deprivation and obesity. But in more walkable areas of the city, this link was broken. And here you can see the impact of spatial layout on health and well-being, as I mentioned previously. Now, these are some examples of another tools also supported by the toolkit, which will help you in understanding complex outcome. So here, the map is a tool for combining different data sets. The first tool is called Line, which refers to Local Insights Explorer. So the line combines basic network properties with more complex data like the walkability and also census data, social behavior, etc. So Line is basically a web-based tool which you can access through your browser. It's powered by the space syntax data and analysis, and it explains how the built environment enables daily activities and has been developed for use mainly in the public sector. So in this case, buildings are colored based on how walkable the built environment are. So the red buildings refers for easier environments to walk, and the blue refers for difficult. So like you can see in this picture, this red area here highlights that there's not much point in doing walkability campaigns specifically in this area. In this case, you are able to identify opportunity spots for behavioral changes and areas where you need actually to implement new policies. Another interesting example is called the Active Travel Explorer, which is another one of the web tools developed with the integrated urban models. It helps users to understand how the built environment can enable or can inhibit daily activities such as walking or cycling. You can also access this tool through your browser, and you can answer sophisticated questions like, where does the city support walking and cycling? Where does the city does not support walking and cycling, and why? Why is that so, and what you can do about it? And finally, the last tool is called HERE, which is the Healthy Environment Risk Explorer. And this tool helps users to understand links between the built environment design and health outcomes in order to be able to take some targeted actions to address them. Like I said previously, you can answer questions related to jobs that can be accessed within 15 minutes, retail services within 15 minutes, public transport within 15 minutes. It also has the socioeconomic dimension, highlighting areas with income deprivation or areas that are less integrated. So yeah, these are some of the resources and online support tool that you can always refer back to if you have any problems or issues or need to understand more about the concepts, the terms, the use in practice. So this is the Space Syntax Toolkit GitHub. You can access it from this link. You'll find a lot of explanations, useful resources, and links to download the software. And if you have any issues, I advise you to use this link. You will find a lot of answers to you common occurred issues. So if you have any issues, you will find a solution here, and you can look at the questions here as well. And finally, the Space Syntax Toolkit Wiki. This provides a wide range of resources. You can access the Space Syntax online training platform. You also have a handbook for the methodologies and the Space Syntax term, links to download the software, QGIS user guide, and everything you will find through this link. And finally, you can subscribe to the mailing list in order to keep you updated. There's a Space Syntax Toolkit mailing list, and there's another Space Syntax mailing list. And that's all from my side. Thank you very much for listening.
Thank you very much, Mariam. Sorry. So we have some time now. If there are any questions about the first two presentations, feel free to take the floor and ask, or you can type in the chat.
Hi, Felixos. Do you hear me?
You're muted.
I'm muted. Oh, do you hear me now?
Yes.
Okay. Hi all. Hi, Nadia. I just wanted to thank you for providing this wonderful seminar. And many thanks to all the team that organized this 5-day seminar. All sessions are extremely interesting. I forwarded to my students, but I don't see many participating, at least today. I managed to participate today because I'm very interested in all these tools, which I think are not only for practitioners, but for academics and for students are very interesting. So I'm eager to see the application of this. Many thanks to all.
Thank you.
Thank you very much, Yannis. Thank you for participating. And we are happy it's useful.
My pleasure, Nadia.
Just to mention also that we sent the info packs out to everyone, and we will make all of the content of the presentations accessible afterwards, and forward you an email with that as well. If there are no questions now, we can take a short 5-minute break. And
Felixos, I've got one question. I was not able to install the depth map. I downloaded from the site from this week, but I was not. I don't know if the others have been able to install it. And actually, I made a mistake, and then I downloaded that map X3, the other version, which as I understood, it's something different. Okay, I don't know. The others have installed it in their laptops. If it's only me, okay, don't bother. I will fix it.
I will forward the link again. 1 second. So it's this link here. Make sure, I don't know if, so it's available for Mac and Windows, I believe.
Yes, this is the link I used. I've done it twice. I downloaded the files for the Windows version, but I didn't manage to install it. Anyway, maybe it's my laptop only. Felicia, don't bother. I just said if maybe there are others with the same problem. It's only me.
I send another link. You can try also this one.
Okay, thank you. Thank you. I will try it.
Hopefully it works. I tested it before I sent out the email last week, and it was working on my laptop. So
Okay, I will try it and I will let you know. Thank you.
Okay, so we have a 5 minutes break.
yes, let's take 5 minutes. Let's begin at 11:15 again. 7 minutes. Okay, we will see you shortly.
Yes. So what is needed, or what type of data or modeling that we need to run the centrality measurements? So for the centrality measurements, we only need a proper street network segment that is cleaned one. And for the catchment analysis, we might also need to add like the surface points or the destination points that you're going to run the catchment through. And for all these tools, we need the depth map XNet as mentioned previously, and the QGIS and the space statistics toolkit. How does it really work? I will dive deeply into some technicality here to show you how exactly it should be working, using the geo packages for the data that's already provided to you. So yes, first thing, you open the depth map XNet and just leave it behind working in the background. And afterwards, you open the QGIS and you start adding the layers. The geo packages will mainly here will be the street network segments. And then we directly open the space syntax toolkit. From here, we start with the graph analysis, and then here we put the network layer, and we check also that is a segment map or a road center line, because maybe we need, if you check this is meaning that you are telling the toolkit that this street network is ready to analyze. It's not needing any further editing or so. So you can do the analysis directly. And here you insert the radii. And from settings, you can choose to make the choice and the normalization types. And yes, all of these stuff there. Yes. And after we make the calculation start, you will find automatically that a new layer will be added into your layers. And now we need to visualize the results or the output of it. And one way to do this is using the QGIS symbology, was already Mariam mentioned. And other way is to do the attributed explore, which is also embedded in QGIS. So you can visualize, they have put in already some of the symbologies that are embedded in the QGIS. You can easily visualize. So when you click this one, you will have this new window, and then you select the new network layer, and clicking on whatever analysis or results that you have, you can automatically, you will find this on the left-hand side, this visually appealing to you. And here is where you can even furthermore edit or yes, play bit or manipulate the visualization a bit if you want, like choosing in different symbology category, and also identify maybe the width or the range or how they are statistically divided. You can also do it from the QGIS itself. And yes, and afterwards also if you want, you can check like the value for the integration of each segment. So you can open the attribute table after selecting the new layer that you have been already have. You can open the attribute table from here and you can select the segment that you want and you can easily find the absolute value for your segments after running this. Now, if you want to test scenarios on how effective adding another bridge or adding a line or removing, how you can do this. So now you need to put the street network into the edit mode. So we put it from here, this pencil type, and then you can choose to add or remove lines, and then you can easily just add or delete more lines to your network. And then you need to run the whole process again for running the graphical analysis and then visualize it. So we have another map added to you. So you can compare results to find what I've shown you previously. So you can test now scenarios visualized. So you see like an after and before to scenarios. For the catchment analysis, we need to input the point of interest layer. So we have already a network now. We add the point of interest and we go to the catchment analyzer. It will open a new window. Here we select the network and you choose if you want to the existing or the one that you already modified. And then you select here the point of interest or the origins that you want to analyze. And here you also specify the radius. And just click run. And this is a default result that will directly add another layer to your layers with this visualization showing you how you can reach these points. And now I think you can easily identify maybe if you have gaps or overlaps between the certain points within the network. And yes, and now you can test more scenarios about this catchment using this way. And I think yes, mainly that's it. I'll stop sharing. Thank you.
Okay, thank you very much, Walid. I will do a quick presentation now about the potentials of spatial analysis and analyzing, visualizing, and interpreting these results. So, share my screen. Do you see my screen? Not the presenter one, right? Yeah. Okay, good. So, as mentioned, sorry. Okay, the presentation is about analyzing, visualizing, and interpreting results. So following the kind of technical overview, we will focus now on what we do after we generate the spatial data. So it's important to know that analysis by itself doesn't really offer us insight. So how we visualize and interpret the analysis that we have carried out is really important to support the planning and design. So it's not just what does the data say, but also what does the data, what this means spatially, socially, and functionally. So the representations are interpretive tools. As you saw, In the examples that Walid showed before, many of the representations have this kind of heat map visualization. And different color bands suggest different things, and there are kind of different kinds of analysis. And it's important to note that we don't read these maps like in terms of high scores, let's say. So it doesn't necessarily mean that blue is bad when you're looking at one of these visualizations and red is good. It really depends on what you want different areas of the city and streets to be doing. So the power of these representations is really showing us the relationship between spaces and streets. So you can have quiet back streets that are deeply embedded in the network that are potentially still important for local access or spatial hierarchy, even if they have a low absolute value. So these visuals, and I'll get to the actual visuals in just a minute, are useful to compare how different streets relate to each other, which ones are central, which ones are peripheral, which paths are likely to be used more, and when we get into interventions, how they might redistribute movement flows, or in other cases, improve visibility. So just to stress that it's not so much about the exact numerical value, but more about what the configuration is telling us about potential use, movement, and social interaction. So on the left here, we see an angular integration representation at the 500-meter radius for the south part of Lefkosia. 500-meter radius, and we'll get back to that. Basically, it's done for pedestrian movement. So angular integration is a measure very commonly used to show how easily a street or path can be reached from other places in the network based on the number of direction changes or angles needed to get there. So in a way, angular integration measures mental distance. This is kind of my way of remembering it. It measures how many turns you need to make and how sharp in terms of angles those turns are. So streets with high angular integration require very few require very few turns from other streets in order to reach them, while streets with low angular integration require many sharp turns to get to, which means they are less visible and harder to access. So if you remember the example shown by Nadia in the beginning, where you have a path that is the shortest path, however, it makes a lot of different turns, and you're changing direction constantly, whereas you have a slightly longer path that is a gentle curve and following a generally straight path. People are much more likely to follow the simplest and the path with the least changes of direction and least angle. So usually angular integration is represented as we see here with a kind of heat map where blue is low integration and red is high integration. I'm reminding that this doesn't mean that red is good, blue is bad. Different streets have different purposes. So moving to the next slide, we are jumping in the scale of analysis. So if we see here, we are looking at angular integration for a 500-meter radius, which is specifically for pedestrians. If we go to the next slide, we are looking at angular integration at a 2,000-meter radius, 2-kilometer radius. So it could be for pedestrians, but maybe cycling. It could also involve short trips by car. It's kind of a different scale of movement. So as we change here, you notice immediately that the centrality hotspots shift. So certain streets that are central in the 500-meter map, they might be less central to 2-kilometer map because they're only well-connected locally and not citywide. However, what tends to happen is that streets that are central at different scales, and you can see this as well, that, for example, the center of the city becomes more red in the second map, even though you already see that it is central and well integrated in the previous map. And at the 2 kilometer radius of analysis, which streets can we see becoming more prominent and becoming more red? This is likely the ones that have long straight lines and less turns. And this means that they are important for cross-city navigation. Whether they are used locally less or more is not important at this scale. So if we look at them side by side, on the left, we have the angular integration at the radius of 2 kilometers. On the right, angular integration at a radius of 500 meters. These different maps show us different things. So the 500-meter radius is showing us local integration. How easily a space connects to other within a short walking distance, let's say 5 to 7 minutes. So this is the neighborhood level, really. Whereas, as mentioned, the 2 kilometer radius is showing us more global integration, longer range accessibility. So how well a segment connects to the wider city network. And this is useful for understanding urban scale movement patterns. So, for example, if we were designing a local plaza, which map do you think would be more useful from these? Feel free to jump in. 500 meters, exactly. But if we were designing a new bus station, or we don't have a larger scale transport, but in other cities, maybe a metro station or something like this, obviously the analysis that shows us the scale of the city is more useful. So it's important when looking at these kind of analyses to ask what kind of user and what function we are addressing. Are we designing for a child that is walking to school? Are we designing for someone biking to work? Are we designing for someone crossing the city with public transport? So moving on, another kind of, and Mariam actually mentioned these two different kinds of analysis before. So apart from integration, another kind of analysis is betweenness. And again, angular betweenness is a very common measure of betweenness. So this is about movement through space. So it mentions how often a street segment lies on the straightest routes. So the routes with the fewest and least sharp turns in the network. So to put it very simply, what we're asking is how likely is it that people will pass through this space to get to somewhere else? So this is different from integration, which looks at how accessible a location is, which is looking more at to movement. And here we're looking at through movement. So how these streets perform as connectors. So streets with a high angular betweenness are those that often form natural shortcuts. So straight continuous paths that help link distant places. And these are often visualized in a kind of different way using a single color. So from darkest to bright in the case of a dark background, or when you have a light background, you use a lighter color for the lower values and a brighter color for the higher values. And again, so I don't know how well you can see this, but this is the same kind of map of Lefkosia, visualized for angular betweenness, and you kind of see a very different pattern than you would see, for example, for the centrality, the angular integration analysis. So here we see it at a 2,000 meter radius. And jumping to the next slide, I wanted to put this because we have talked about the kind of scale of the analysis, but there's also something to be said about the scale of visualization. So in this case, this map on the left is also at the 1,000 meter radius. the calculations stay exactly the same that the software is performing, but it really makes a difference what we can see and understand how far we zoom in or out. So when we zoom in, we definitely see more information about the local level, which exact segments or junctions carry the most through movement. And this can help us identify specific design opportunities, for example, that have to do with pedestrian movement or movement with vehicles. But when we zoom out, we understand the broader structure of movement across the city. So which major corridors act as regional connectors and how they relate to each other. And this is more useful for strategic planning. So again, this only has to do about the kind of the scale of what we can see. And it's again useful for different things. So for the following kind of visualizations, we've zoomed in really far, and we're looking now at we'll do a comparison kind of the old University of Cyprus campus, the Kallipoleos campus, for those of us that are here in person, and discuss a bit about how it relates to the new university campus in Aglanja. So, looking at this map on the left of the screen, I've marked where the campus is, and you can see from the heat map the kind of levels of angular integration at a 500-meter radius. Have a look at this for a few seconds, and can anyone tell me what we can understand about the walkability of the campus from this map? Any thoughts? What positives or negatives can you consider in this map? If you are on Zoom, feel free to jump in. Same in person.
Frictions probably that it's not very easy to navigate to the University of Cyprus. I thought.
Am I muted? Sorry.
Frictions, do you hear me?
Apologies. Sorry, I had my laptop muted. Can you share with us again?
Do you hear me, Frictions?
Yes, yes.
You're not muted. We could hear you very well.
Yes, but we could not hear you.
Okay. Yeah, I said probably that it's quite difficult to navigate to the University of Cyprus, to the campus there.
Yes, exactly. And again, I want to say that this is not necessarily a good or a bad thing. It could be argued, for example, that sorry, I'm trying to. Okay, do you see my screen or the presenter view? Screen, good. So the University of Campus, we could say, for example, maybe it's intentional that it's not so well integrated, that you have a quiet place of study, and it doesn't need to be so well connected. Or on the other hand, it could be a negative that actually it's not very well connected, it's difficult for people to reach. So this is something that is kind of up to our interpretation and analysis, depending on what a space wants to achieve. So what if we move to the campus in Aglanja? What do we see about this? And maybe if anyone can see how this differs from the other map. So maybe let's look at them side to side already. So on the right, we have Aglanja. On the left, we have the city center Kallipoleos campus. Can someone say one similarity and one difference between these two maps? Dimitri, Stavros, since you guys are here, maybe you can. Sure, yeah.
So maybe a similarity, we can see the boundary of the campus on both sides. And the difference for me is on the right side for the main campus, we can see that you can pass with your car because of the streets. So the streets, it's kind of connected with the city instead of Kallipoleos, that there are only two entrances and then you have to walk through the site.
Okay, thank you. Does anyone want to add anything? Feel free, or else I'll.
I see that the Kallipoleos site is more close to a more integrated place, which means that they are very close to areas. I think location is very, very good because on the very local scale, it's not very integrated, which means, as you said, it's very quiet, so it's a very good area you can study. But once you go out, you can reach multiple things.
Exactly. Exactly. So the clearest difference is exactly what Walid mentioned, that on the left map, we can kind of see the city campus adjacent to the city center, very nearby. Whereas on the right, we see that this whole area, especially if we look at these maps, the area is quite far from the city center and a little bit segregated. So the similar thing is that kind of at the level of local integration, we can see that the two campuses perform in a similar way. That means that in terms of their immediate surroundings, they are not so well connected, which, okay, in the case of Cyprus, my assumption would be that it is less to do with, let's say, planning that we need a quiet area for study. I think it has more to do that there is poor pedestrian access and planning across the city. And as Stavros also mentioned, especially in the Aglanja campus, it's almost taken for granted that a large amount of people arrive by car. So hopefully these examples have given you some food for thought for the exercise we will do afterwards. I wanted to wrap up with some few key takeaways. So firstly, just giving a reminder of what these two metrics are, angular integration and angular betweenness. Angular integration gives us a sense of how central a space or a street is, how easily it can be reached from everywhere else. And this is a strong indicator of places that attract movement, services, or gathering, as both Mariam and Nadia mentioned earlier. Then, if we look at angular betweenness, this tells us something different. This tells us how often a street is a connector, how often it is a link in the straightest route between destinations. So this is through movement, whereas integration is to movement in regards to a space. So this is to say that the kind of analysis really matters in what we're looking at and what we want to understand. The scale of analysis really matters. So at a radius of 500 meters, we can understand a space's performance in its immediate locality, in its neighborhood, which is useful for things like considering walkability or if we want to design a local square. At 2 kilometers, we start to see city scale patterns, which is great for planning transit or identifying strategic corridors of movement. We need to remember that, as mentioned in the beginning, the visualization does not automatically mean interpretation. These maps, they don't interpret themselves. Just because a street is red or blue, it doesn't mean that it's immediately successful or problematic. It really depends on the context, purpose, and how people actually use it compared to its intended use. So actually, if there's one thing to take away from this presentation is this, that it's really important to interpret what you have in front of you, and it's not that well integrated and central means necessarily good, and that less connected means bad. So when using these tools, it's important to ask, who is moving here? Why might this space feel accessible or cut off? Do we want it to perform like this? Are the spatial patterns that we see supporting or undermining the space's intended use? So looking ahead towards the exercise that we will do, and for our students, especially the work we will do in the coming 1.5 weeks, spatial analysis is not at all the end of the design process. It's really the beginning of a design process. So these tools, they don't give us definite answers. What they do is they help us ask better questions. So to connect also to the mini courses that we have been doing these past few days as well, it's important to combine this spatial analysis with qualitative methods, with observations, how people actually move and use and feel in a space, as well as community inputs when possible with focus groups, workshops, because people often navigate in ways that the maps can't fully predict, while they give us a good idea and a good sense of what might be going on. It's important to take into account informal, historic, or emotionally charged spaces and how these interact with the kind of quantitative data that spatial analysis produces. And as mentioned in previous presentations, I'll highlight it again now, that qualitative and participatory methods are key components of complementing the quantitative data that we can produce with spatial analysis. And again, I will end with this question, this kind of key moment of interpretation, where the spatial analysis is really helping us to think if the spatial layout is helping or hindering the intended function of a place. So I'll end there.